Welcome to my new video, students. Today we are going to study the charging and discharging of capacitor. We are going to charge the capacitor first and then we are going to discharge it. So we are first going to charge the capacitor and then we are going to discharge the capacitor. Okay, first we are going to charge the capacitor until it gets completely charged and then we are going to discharge it. And during both the time we are going to note the voltage across the resistor. And we'll see the voltage drop across the resistor. Let's do the circuit connections. First, we are going to connect the capacitor and resistor. Okay, so we have connected the capacitor and resistor, and then we are going to give the power supply. So we'll connect the voltage source to our circuit. We are connecting the voltage source to our circuit. Both positive and negative are connected to the circuit. And now we are going to put the key here. This is a charging key and the upper circuit is the charging circuit. As you can see, we have this circuit connection. Here we have capacitor and resistors which are now interconnected, and the upper part is the charging and the lower part is the discharging circuit. So now we are going to use the digital multimeter. This is the digital multimeter, and digital multimeter is used to measure the voltage across resistor. So we are going to measure the voltage across the resistor using the digital multimeter. So using this DMM, we are going to measure the voltage across the resistor. Hence, we are going to connect it across the resistor. As you can note, when we begin the experiment, when the capacitor is charging, you can see the voltage was 19 point something because we have provided 20 volts power supply, and we can see after every 10 seconds we have to note the decrease in the voltage. Okay, after every 10 seconds of charging, during the process of charging, after every 10 seconds we are going to note the decrease in the voltage drop, and this is what we see, the decrease in the decrease. There is a voltage after every 10 seconds. Okay, and we are going to note it until the voltage drops to around 0. You can see now our voltage across the resistor is around 4.83. It's around 4.6, so it's dropping, and note it along with the time. Okay, yeah, so we are going to note the value. Yeah, so this is the value, 3.3 for around 100 seconds. We have got this value, and see, now we have got around 0.43. So 0.43, and now we are going to discharge it. Let's see the voltage during discharge. Minus 19.9 was the voltage for 0 seconds discharge. So during discharging of the capacitor, we are going to note the voltage across the resistance after every 10 seconds. And then what we are going to do is, from the formula V is equal to IR, that is Ohm's law, we are going to determine the current I. And from the I, we are going to determine the value of I square, that is square of current, and then plot a graph of I square versus T during both charging as well as discharging. So we are going to plot two graphs, one for charging, one for discharging of the capacitor, and for both the graphs I square versus T is plotted. Okay, and then we are going to measure the area under the curve. Thank you. Please like, share and subscribe, students. Thank you so much.